The number on the printout was 218. That is what I was staring at when I sat down at my kitchen table with a cup of black coffee and my yellow highlighter. My doctor's office had called a few days before to tell me my labs looked fine. When the actual paper finally arrived, I could see why they said that. The standard reference range at my lab starts at 200 picograms per milliliter. My B12 came back at 218, right above the line. Technically normal. At least, that is what I thought. Because I had been taking a B12 supplement every single morning for 6 years. I read somewhere in my early 60s that B12 mattered as you got older. I bought a bottle at the drugstore, and I kept buying them. But I was still dragging myself out of bed, feeling like I had not slept. My right hand would go numb at night, usually around 2 in the morning. My concentration had gotten foggy in a way I kept blaming on bad sleep or stress or just being 66 and not being 40 anymore. I figured that was what 66 felt like. The pharmacist is the one who changed my thinking on that. I stopped in one afternoon to pick up a prescription, and he glanced at the bag on the counter, looked at me, and said, "Are you taking a B12 supplement? Because with what you're on here, I want to show you something." 5 minutes later, I understood something that 6 years of daily supplements had never taught me. Before we go any further, let me be clear about who I am. My name is Wayne Ellison. I am 68. I have no medical credentials whatsoever. I am not a doctor, and nothing in this video is medical advice. It is educational. What that pharmacist showed me sent me back to read the actual research, including guidance from the NIH, from the American Diabetes Association, and from the Mayo Clinic. That is what I am walking you through today. But before you change anything, bring what I show you to your own doctor first. Here is what I found. 5 things I was getting wrong about B12, and 4 of them came down to things that nobody had ever explained to me in a 10-minute appointment. There is no procedure code for walk the patient through the absorption mechanism, so nobody walked me through it. How does someone take B12 every single morning for 6 years and still come up short? That is the question that started this, and the answer surprised me. Number 1. The pharmacist picked up my supplement bottle first. He flipped it to the ingredient label and pointed to the active ingredient, cyanocobalamin. He asked if I knew what that was. I did not. Cyanocobalamin is a synthetic form of vitamin B12. It is the form used in the majority of standard supplements because it is inexpensive to manufacture and it keeps well on a shelf. But it is not the form your body actually uses at the cellular level. Your body has to convert cyanocobalamin before it can use it. The conversion runs through several steps and ends up at one of the 2 active forms, methylcobalamin or adenosylcobalamin. That conversion process happens mainly in the liver. Research published in nutritional biochemistry literature and referenced by the NIH notes that this conversion can vary depending on your genetics, your liver function, and changes in how your metabolism handles micronutrients as you age. For most younger adults, the conversion happens efficiently enough that it does not matter much. But after 60, there are more places in that chain for something to slow down or not work as well as it once did. I had been swallowing 1,000 micrograms of cyanocobalamin every morning and congratulating myself for taking care of my health. What I did not know was that my body was doing extra conversion work before any of it became useful, and that work was getting less reliable. This choice seemed small at the time. It was not. The form to look for is methylcobalamin. It is the active form. Your body can use it directly without running it through that multi-step conversion process. It costs a little more than generic cyanocobalamin, but it is available at most pharmacies and health food stores. Ask your pharmacist which brands carry it. That was problem number 1. But even after switching the form, there was a deeper issue waiting, and it had to do with what age does to the absorption process itself. Number 2. For a while, I told myself the form was the whole answer. Swap the supplement, problem solved. That turned out to be too simple. Here is how vitamin B12 actually moves from the food you eat or the supplement you swallow into your bloodstream. It is a 2-step process, and both steps can fail after 60. Step 1. Your stomach produces acid. That acid breaks the chemical bond between B12 and the protein it is attached to in food, releasing the B12 so it can move forward through digestion. Step 2. Specialized cells in your stomach lining produce a protein called intrinsic factor. Intrinsic factor binds to the free B12 and carries it through the wall of your small intestine into your bloodstream. Both of those steps depend on a stomach that is working well. After 60, a condition called atrophic gastritis becomes more common. The stomach lining becomes less active. It produces less acid. It produces less intrinsic factor. The NIH, National Institute on Aging, has noted that this condition affects a significant portion of older adults, with estimates as of 2026 suggesting it may be present in a meaningful share of people over 50. The ranges vary by study, but the direction is consistent. The older you are, the more likely your stomach is producing less of what it needs to absorb B12 efficiently. I mean, think about that for a second. You could be eating salmon twice a week and taking your supplement every morning, and your gut may simply not be pulling the B12 across into your bloodstream the way it did 10 years ago. The B12 is there. The absorption mechanism is the problem. The NIH has recommended for many years that adults over 50 get B12 from supplements or fortified foods rather than food alone, because the crystalline form in supplements does not need to be released from protein by stomach acid, which bypasses step 1. But here is the detail that everyone missed at the time. Most oral B12 tablets, even the crystalline form, still need intrinsic factor to cross the intestinal wall in your small intestine. If your stomach is producing less intrinsic factor, you can swallow a high-dose tablet every morning and still not absorb much of it at all. There is a solution to this problem, and I will get to it in a moment. But there is a third issue that the pharmacist showed me, and it is the one I most wish someone had mentioned earlier. Number 3. The pharmacist did not start with my supplement. He started with my prescription bag. There were 2 items in it. One was a blood pressure medication. The other was omeprazole, 40 milligrams, which I had been taking for about 3 years for acid reflux. My doctor had written that prescription at the end of an appointment. I filled it the same afternoon, and I had not thought much about it since. The pharmacist said, "Do you understand how this one works?" I knew it reduced stomach acid. That is the mechanism. That is why it helps with reflux. What I had never connected was what that means for B12 absorption. A proton pump inhibitor, the class of drug that includes omeprazole, works by suppressing the acid-producing pumps in your stomach. That is the entire point. And as we just covered, your stomach needs acid to release B12 from food protein during digestion. Research cited by the NIH and published in peer-reviewed journals has associated long-term PPI use with lower B12 levels. The most commonly prescribed PPIs include omeprazole, lansoprazole, pantoprazole, and esomeprazole. These are among the most prescribed drugs in the country for adults over 60 as of 2026. And in 3 years of refilling omeprazole, nobody had ever connected that prescription to my B12 levels. And no, I am not making that up. There is no appointment time built in for explain the B12 absorption mechanism. The prescription gets refilled, and the connection does not come up unless you bring it to the table yourself. H2 blockers, including famotidine, work through a different pathway but also reduce stomach acid, with a similar downstream effect on B12 absorption. If that sounds bad, keep watching. Because the second drug connection the pharmacist showed me that afternoon may be the one that matters most to the people watching this video. If you are on metformin for blood sugar or type 2 diabetes, this is directly relevant to you. Metformin is one of the most widely prescribed drugs in the country for managing high blood sugar. It is inexpensive, it has a long track record, and it does important work. But the American Diabetes Association, as of 2026, recommends that people on long-term metformin have their B12 levels monitored regularly. The reason is specific. Metformin does not only reduce stomach acid, it competes with the mechanism in the small intestine that pulls B12 across the intestinal wall. The interference is direct. Metformin competes with the intestinal absorption mechanism itself, separate from the acid question entirely. That is not a reason to stop metformin. Please do not hear it that way. And please do not change any medication without talking to your doctor first. Metformin does real work for a lot of people. The point here is that if you are on it and nobody has talked to you about your B12 levels, that is a gap worth closing. You can ask your doctor directly, "I have been on metformin for a while. Should I be monitoring my B12?" That is a reasonable question to walk in with. Which brings me to the part that changed how I thought about the testing itself. Number 4. Here is why I walked out of a lab appointment with a normal result while still feeling the way I did. The standard blood test for B12 measures your total serum B12. It counts all the B12 in your bloodstream and gives you a single number. Most labs flag anything above 200 picograms per milliliter as within the normal range. But research in clinical nutritional medicine, including work published in peer-reviewed journals indexed by PubMed, has documented cases where people develop functional B12 deficiency at the tissue level, even when their serum number falls within the standard range. The serum level tells you how much B12 is in your blood. It does not directly tell you whether B12 is actually being used by your cells. If you wonder how that is even possible, so did I. Here is the short version. Vitamin B12 is required for a specific process inside your cells. When B12 is not available at the cellular level, a byproduct called methylmalonyl-CoA builds up and converts to methylmalonic acid, or MMA. So when B12 is truly deficient in your tissues, MMA rises in your blood and urine. That rise can happen even when the serum number looks fine. The second marker is homocysteine. B12 is needed to convert homocysteine into another compound called methionine. When B12 is functionally low, homocysteine accumulates. Researchers at institutions, including the Cleveland Clinic, have associated elevated homocysteine with increased cardiovascular risk over time. According to literature current as of 2026, both MMA and homocysteine are standard lab tests. They are not specialized panels. They do not require a referral to a specialist. Your primary care doctor can order them on the same requisition form as your routine blood work. Write this down and bring it to your next appointment. Ask for a serum B12, a methylmalonic acid level, and a homocysteine panel. Tell your doctor you want the full B12 picture. Serum B12, methylmalonic acid, and homocysteine together. That covers both what is in your blood and whether it is actually working at the cellular level. That detail was a warning sign. I had been ignoring it for years because I did not know the warning existed. Most people never heard about this part. They get the serum B12 number back, hear normal, and leave satisfied. But a normal serum level alongside elevated MMA tells a different story entirely. And the only way to see that story is to ask for the right tests. Before I get to the last thing, which is the actual change I made and what happened with my numbers afterward, I want to ask you something. If this is the kind of information you have been looking for, hit subscribe. I read the comments on this channel, and I would genuinely like to know what number you are trying to get down. Blood pressure? Blood sugar? Cholesterol? Something else? Tell me in the comments, and I will get back to you. While all of this was happening with my B12, I kept running into the same broader pattern with other nutrients. Something important to health, a simple test to find it, an inexpensive fix, and a mechanism that takes longer than 10 minutes to explain. That is what sent me into the research myself. And the last piece of the B12 puzzle is the most practical one, because it is the piece you can act on most directly. Number 5. The Pharmacist's specific recommendation was to switch from cyanocobalamin tablets to sublingual methylcobalamin. Sublingual means under the tongue. You place a small tablet or a few drops under your tongue and let it sit there for about a minute before swallowing. Here is why the delivery route matters. Tissue under your tongue has a dense network of capillaries, small blood vessels sitting very close to the surface. Compounds that dissolve there can pass directly into those capillaries and enter your bloodstream without passing through your stomach or your small intestine at all. So the stomach acid problem does not apply. The intrinsic factor problem does not apply. The medication interference is reduced significantly. The B12 moves into your blood through a different door entirely. Sublingual B12 delivery has been studied for decades. The Mayo Clinic has noted sublingual administration as one way to improve B12 uptake for people who have absorption difficulties with standard oral supplements. The absorption pathway is well established, and the rationale is straightforward. What dose is appropriate for you is something to work out with your doctor based on your specific lab results. The NIH publishes guidance on B12 for adults over 50, and your doctor can review that guidance with your numbers in front of them. I am not going to give you a number to take because your situation is yours and I am not the right person to make that call. What I can tell you is what I also changed on the food side, because the supplement and the diet work together. Vitamin B12 is found in animal proteins. Beef liver has the most concentrated natural B12 of any food in the typical diet. Clams are also high, as is salmon, sardines, beef, and eggs. I started keeping canned sardines in the pantry because they are inexpensive and require nothing to prepare. I eat salmon at least twice a week. I add eggs to breakfast more often. These were not difficult changes, they were just consistent ones. 3 months after switching to sublingual methylcobalamin, I went back for follow-up blood work. My MMA had come down, my serum B12 had moved up, and the brain fog I had been blaming on getting older started to lift in a way that made me reconsider whether it had been about getting older at all. I am not going to call it a cure. That is not an accurate word for what happened. I am calling it a correction. A correction to something I had been doing wrong for 6 years, and that I only found out about because a pharmacist had 5 minutes and chose to use them. That lab printout is still on my kitchen table, actually. Different tests now, newer numbers. But I still use the same yellow highlighter. Let me bring this back to the 5 things, because they cover it all. The form matters. Cyanocobalamin is the synthetic form found in most standard supplements. Your body has to convert it before it can use it, and that conversion gets less reliable as you age. Methylcobalamin is the active form. If your supplement says cyanocobalamin on the label, ask your pharmacist about switching. The absorption pathway can fail after 60. Your stomach produces less acid and less intrinsic factor as you age. The NIH National Institute on Aging has documented this. Both of those reductions make it harder to absorb B12 from food and from most oral tablets. Sublingual delivery bypasses the problem. Certain medications reduce B12 directly. Proton pump inhibitors reduce stomach acid, which is the first step in B12 absorption from food. Metformin interferes with the intestinal absorption mechanism directly. The American Diabetes Association recommends B12 monitoring for people on long-term metformin as of 2026. H2 blockers have a similar acid-reducing effect. If you are on any of these, ask your doctor whether your B12 should be monitored more closely. The serum B12 test alone does not give you the full picture. Ask for methylmalonic acid and homocysteine along with your standard serum B12. Those 2 markers tell you whether B12 is working at the cellular level. Sublingual methylcobalamin bypasses the absorption barriers. It absorbs through the tissue under your tongue, directly into the bloodstream, without going through the stomach at all. This is what worked for me. None of this cost me much. A different form of supplement, 2 cans of sardines a week, and 3 questions I finally knew how to ask. Write down those questions. Bring the list to your next appointment. Talk to your doctor before you change anything, especially if you are on any medication. Write it down so you actually say it when you get there. If this helped, subscribe and leave me a comment telling me what number you are working on. I am 68 and I am still figuring things out too. I will see you in the next one.